right, 5th grade, your challenge is going to be a division problem. I am going to show you a few different examples of ways you could solve a division problem, and then when you get your challenge problem, you can solve it whichever way you like. So let me put a sample division problem up here. Let's do 1,257 divided by 32. That could also look like or it could even look like a fraction. They all really mean the same thing though. They mean how many times would 32 fit inside of 1,257? Or you can think 32 times what number would get you up to 1,257. So the first strategy I'm going to show you guys is thinking with this multiplication, multiplying up. Okay, so I'm going to use a model that you're probably familiar with multiplication, which is an area model. So I'm going to be thinking about chunks of 32 or groups of 32 that I can pull out of 1,257. And whenever I'm trying to pull out groups, I usually try to think of nice easy factors. So like 1, 2, 5, 10, 20, 50, 100. So let's just start for this one. Let's see, 32 times 10, that would be 320, right? But I know I can fit at least two 320s, because two 320s would be 640, right? I could fit that into here almost twice. Let's try 32 times 20. Remember, 32 times 10 would be 320. So 32 times 20 would be 640. It would be double that, right? So I'm pulling out 640. That leaves me with 617. I had a feeling I wasn't going to be able to do that twice. So maybe for this next one, I might pull out 10 groups of 32. When I pull out 10 groups of 32, that is going to be the same as pulling out 320. So let me try that. I think about this as 61 tens minus 32 tens, but I go 61 minus 31 would be 30, and then take off that extra 1 since it's 32, and that would be 29 tens or 290. So now I'm at 297. I cannot do another 10 32s because 320 is greater than 297. So why don't I think about what would be half as much, since 5 is half of 10. I wonder what is half of 320. Let me think about that. Half of 300 is 150, and half of 20 is 10. So 150 and then 10 more would be 160. So that means 5 groups of 32 would be 160. I'm going to take that out next. So now I have 137. I can't take away 5 more 32s because 160 is greater than 137. But I know I'm not that far off. So what if I just took away 4 32s? I know 4 32s is going to be 32 less than 160. So 160 minus 30 would be 130. Minus 2 more would be 128. So when I take off 128, let's see, 37 minus 28. Well, 37 minus 27 would be 10. Minus another one off would be 9. Which would leave me, since it's 100 minus 100, a remainder of 9. Okay, so let's see exactly how many 32s could I pull out of 1,257. 20 32s got me to 640. 10 32s added on was 320. And then 5 more 32s and 4 more 32s. That got me a total of 30, and 9 is 39 32s. So that means that 32 times 39, I just have to add on that remainder of 9, would get me up to 1,257. I can even just check just to make sure. 600, since I know that 32 times 39, I already did the work up here, right? So 640 plus 320, that's 940, 50, 60, 960. And then 160 plus 128 would be 288. Oops. So there I'm at 1,248. I just need to add that 9 on there. When I add 9, I always think add 10 and take 1 off. So 1,248 plus 10 would be 1,258. But then since that's 1 extra, I would have to take it off. So 1,257, which is exactly what I started with. So I know that I'm correct. So when I have 1,257 divided by 32, I know that the quotient is 39 with a remainder of 9. So that strategy is called multiplying up. The second strategy I'm going to show you is one of my favorites. Let me draw myself a little line so I don't get confused. And I'll even use different numbers just to explain it. Let's try 2,349, and I'll divide that by 53. This strategy is called partial quotients. So I'm going to find the quotient, but I'm going to be pulling it out in chunks. It's kind of more makes me think of repeated subtraction than multiplying up. So let's see, I'm thinking still how many 53s would fit into 2,349. All right, I'm trying to do a little bit of estimating right here. So let me think about this. 53 times 10, and I'll just write this off to the side so you guys can see my thinking. That would be 530. And I know that 530 is about 500, and about 4 500s fit inside of 2,000. So I bet that I might be able to do it by 40, but let me just double it. I'll do 53 times 20. So I have twice as many 53s, so that would be 1,060. I'm going to try that at first, okay? So I'm going to take out 20 groups of 53. When I take out 20 groups of 53, that's the same as taking out 1,060. That leaves me with, let's see, 34 minus 4 would be 30, minus 2 more would be 28. 1,289. And just as I suspected, I could take out another 20. I knew it was close to 40, but I wasn't sure. The thing that I love about partial quotients and multiplying up is I can take out these groups of 53 in chunks that make sense to me. So it might make my work a little bit longer, but if it makes sense to me, that's worth it. So now I'm down to 229. I know I definitely can't take out 20 more 53s. I'm thinking that 50 goes into 100 2 times, so it's probably 53 will probably go into about 229. Let's try double that. Let's try 4 times. So when I think of 53 times 4, I'm just going to break it up into 50 times 4 and then 3 times 4 and put those partial products together. 50 times 2 is 100, so 50 times 4 would be 200. And then 3 times 4 is 12. So 200 and then 12 together would be 212. So that means that 4 groups of 53, or 4 times 53, is 212. I'm going to take that out now. All right, so that leaves me with 17, which is less than 53. So I know that that's my remainder now. So now if I want to see how many 53s I was able to fit into 2,349, all I have to do is put these partial quotients together. And then 20 and 20 makes 40, and then 4 more is 44. So that makes my quotient 44 with a remainder of 17. And that's partial quotients. So now you have seen multiplying up, and you have seen partial quotients. The last strategy I'm going to show you is going to be one that might be more comfortable for some of your parents. It's very similar to how many of us learned in school. It's not exactly the same because I like to use strategies that don't ignore place value. So I'm going to show you a modified long division. Students do not need to learn the long division algorithm in elementary school. They don't technically have to learn that until middle school. And it's not something that you want to rush because you want students to actually understand what is happening when they're doing division. So let's take a problem like 8,425 and let's divide it by 32. So you'll notice it's not going to look too much different from that traditional long division algorithm that many of us learned, moms and dads and family members, but it's going to be just slightly different so that we don't forget about place value and the size of the numbers as we are taking out the chunks, okay? So back in the day, our teachers would say things like 32 doesn't go into 8, 32 goes into 84 2 times, right? Well, when we're saying 32 goes into 84, what we're really talking about is that 32 can fit inside of 8,400 200 times. So 32, since I'll even start, 2 32s is 64. So 20 32s, it's going to be 10 times that much. It would be 640. So that means that 232s is going to be 6,400. So let's see, if I had taken 232s out of this number, then I would really be taking out 6,400. Make sense? A little bit. That leaves me with 2,025. Okay, so now I need to get to 2,025. I'm thinking about 32 times what would get me close to 2,025. And I'm just going to start with an estimate of 100 times 32. 100 times 32, that is going to be 3,200 or 3,200. That's going to be too much. So what if we just did half that much? Because remember, I like using those easy chunks. Half of 100 is 50. So in order to figure out 50 times 32, I can just half my product of 100 times 32. So half of 3,000 is 1,500, and half of 200 is 100. So when I put 1,500 and 100 together, that would get me 1,600 for 50 groups of 32. So let me take out those 50 groups of 32, and I said that's going to be the same as taking out 1,600. So now I'm down to 425. I'm just going to take out another 10 32s. because 10 times 32, or 10 groups of 32, is going to be 320. And that's going to get me to 105. And now I'm kind of estimating how many 32s fit into 105. Well, I know 3 times 30 is 90, so I'm just going to try 3. I think that's pretty close. So 3 times 32, I'm thinking 3 times 30 is 90, and 3 times 2 is 6. So 3 times 32 would be 96. So I'm gonna use a little over strategy here. 105 minus 100 would be 5, but I'm not taking away the whole 100. I need to give 4 back, so that would be a remainder of 9. If you don't understand what I was talking about with those strategies I was using to subtract, you can still go through and do your traditional subtraction if that makes sense to you. I just don't like regrouping. I like to avoid it as much as possible. So now when I'm looking to see what the quotient is, I have up here 200, then 50, then 10, then 3. So that's actually 263 with a remainder of 9. And so parents, when you look at this work here, it's really not much longer than that long division that we learned. But instead of doing those arrows to bring digits down, we just are keeping those zeros as placeholders in there so that we understand the size of that number. So those are 3 strategies that you can use to do division, multiplying up, partial quotients, and a modified long division. So I can't wait to see which strategy you guys use for your division problem, even if it's different from something I have here. Talk to y'all soon.